So what is a moment? Let me just start with the definition. See if we to make sure that we're all on the same page. Just set my colors, and you can go with the title of moment of a force. Moment of a force, or as its other name, torque. So if I want to give you a definition, I actually put a picture of a mechanics trying to tighten a bolt or loosen the point. I don't know, depending on which direction he's pulling or pushing it, using a wrench. Right? So moment of a force is pretty much, let's put it this way: when we apply a force to a body, right, it will produce a tendency. It gives, it provides a tendency, or it gives a tendency to that body to rotate about a point. Right. So we have a rigid body or a body. We apply force to it. That force produces a tendency for that body to rotate about a point. Now, that tendency to rotate is called moment of a force or torque. That's pretty much it. That's the general definition of a torque or moment of a force. So let me just phrase it here. When we, or not we, when a force is applied to a body, it can produce a tendency for, let's say, for the body to rotate about a point. And you can just pretty much say that this tendency is called this tendency, right? Tendency, let's put it this way, to rotate is called torque, or you can call it a moment of a force. Moment of a force, or we simply just refer to it as moment. A lot of time when we are in this course, we don't really say moment of a force, we just say moment in so many cases at least. Now, one thing about that point that the force wants to rotate the body about it is that that point can never be on the line of action of the force. I'll talk about it more later on. But the example here is a very simple example of where we generate a moment of a force. When you're using a wrench to tighten or loosen a bolt, you know, you're applying your force. In this case, the body is the wrench here, and you're applying your force to this, and it creates a tendency in this wrench. You've seen it, you've felt it. A tendency, let's say if you are going this way, there's a tendency to rotate. You're pushing this to rotate, and then your wrench rotates around that point. Now, so this is the definition of moment of a force. Now, moment of a force, like the force itself, is a vector. So meaning that once we have a vector, we said that before, a vector has magnitude and direction. So we are studying the moment, we have to be comfortable with what it is, how to define it, how to describe it, right? That's the whole idea. So let me just put it here. Moment of a force is a vector, right? And as a result, and it has a magnitude and then direction. Magnitude supposed to be D, and a direction. Now let's talk about this magnitude and direction. So the magnitude of this moment, right? I can go to the next. Let me stay here, make sure that if you're taking notes. So the magnitude of this moment is pretty much proportional to the magnitude of the force itself, how much force you're applying, and the perpendicular distance of that force and the point that creating the moment about. This is the perpendicular is important, the word perpendicular in that definition. So let me put it here. This would be, I'm going to use the same color, magnitude. I actually have a good picture. I can use that from one of these textbooks. There you go. This gives a better vision of the magnitude. A view of the magnitude is what I'm talking about. So let's say, I'll put it here. The magnitude is directly proportional to the, let's put it this way, magnitude of the force, right? Force is a vector. Magnitude of force that is generating this moment and the perpendicular distance. And the perpendicular distance. Here, the perpendicular distance in this picture, again, the same guy, same person is trying to apply force on a bolt or a nut and is trying to tighten that bolt. So the force is applied, the magnitude of force, if the magnitude of force is F, and the distance, the perpendicular distance between that force and the point, which is this case is point O, in this case point O, gives us the magnitude of the moment. Right? You can just write it this way. The magnitude of moment about point O is the magnitude of force times the perpendicular distance. We call this perpendicular distance moment arm. Right? So this is, if I want to put it here, this is the moment about O. About O. Well, this is the magnitude of force F, and D, I call it moment arm, which is basically the perpendicular distance. So that would be the magnitude of a moment. Right? The other two concepts are, we already know. D is just distance, is a length. F is force. Right? Well, we already know about force. In this case, F is the magnitude of the force. Now, in terms of directionality of this concept moment, right? Direction, the direction is, as they call it, they define it by moments axis. Right? We had moments arm, now we have moment axis. Now, in 3D space, this axis is, you can follow the right-hand rule. So I actually have also the other picture that can help us visualize what I'm talking about. You're not in class, so I try to use more pictures. Hopefully things are less confusing. If we have a force F, right, take a look at this two-dimensional from top view before you look at this 3D space, 3D vision of right-hand rule. So if I have a force F, right, applied in some specific direction, and I want to find the moment created by this force around point O, call it MO, I can use the right-hand rule. Which way? In a way that my four fingers are along the force, right, pointing the same direction as the force. The palm of my hand is facing the point that I want to find the moment about it. So fingers direction of the force, the palm of my hand facing the point that I want to find the moment about. Then if I start making a fist, right, that is going to be the direction of the moment in 2D space, which is represented here by a blue color, by blue, I guess it is blue, vector, round point O's, MO. Now, if you look in 3D space, like what we have at the top, it's the same story, making a fist, but in 3D space, because again, it's a vector, so that is the direction of the vector. My thumb shows the direction of the vector. So once we start talking about moment in three-dimensional space, you will, that's what we mainly use. We use this direction of the thumb to figure out the direction of the moment. But in 2D, to make things easier and not to use vector notation, we can just go with clockwise or counterclockwise direction. Hopefully it makes sense based on the picture and what I was trying to say. So I don't really, we can just put few words here. The direction of the moment is defined by its, it's good to put it here, its moment axis, because we will talk about this moment axis later on. Right? So a moment has an arm and an axis, which is perpendicular to the plane that includes the force and its moment r. So I said in three-dimensional, think about it as a vector coming out of the plane, well, depending on which direction your force is and which point you're finding the moment about. In 2D space, well, just clockwise or counterclockwise direction.